Okay, so we're going to look at how we can relate lengths to areas. But first of all, just make sure we understand the geometric representations of our powers x squared and x cubed. So square powers represent square areas. So when we talk about squaring something, we're actually making a square. So if I take 3 meters and square it, I'm going to end up with 9 meters squared, or 9 square meters. So I take a side length of 3, so that here this represents a side length. Okay, just going to do it in a different color here. So this is a side length. Okay. Right, and this generates an area. Okay, it generates an area of 9 meters squared. Okay, so there's my area in here. There's my 9 meters squared. I can actually draw my 9 squares in there. Okay, and this represents my side length. Okay, so if I take a side length of 3, and I can take this side or the horizontal side, doesn't really matter. I square it, I make area, or in the area is a square area. Okay, cubic powers or cubes represent volume. So if I take a length of 3 meters, again this is a side length. Okay, so here's my side length. Okay, if I cube it, I'm going to generate volume. Okay, so that represents then volume. So when I cube something, I get volume. Okay, I get a cube, which represents volume. So in this case here, it's hard to draw, but there will be 27 squares in there. Oops. Or sorry, 27 cubes in that space. Okay, it's hard to draw in there, but you can imagine there's 27 cubes in there when I have a 3 by 3 by 3 cube. Now when we get to higher powers, because we don't live in the fourth dimension, it's really hard to imagine powers of force, but they exist, and they exist kind of in the same way. Okay, so we start with 0 dimensions, a point. 1 dimension is a line. I take that line, I extend those points, I get 2 dimensions. Okay, I extend those 4 points, I get 3 dimensions, sorry. Okay, and if I knew how to extend those 8 points in a perpendicular direction, then a mutually perpendicular direction, and then I can get the 4th dimension. In this case, that's kind of hard to imagine. Okay, so that's why 4 dimensions can be a little bit harder to think about. Okay, so when we look at this then, so what are some problems that we can do? Okay, so one of the things we want to look at is how does area change when we change the side length? And what we want to understand is how does the multiplier change? Okay, so if I double, so there's my multiplier. If I double the length and width of a square, okay, so here's my original square, and if I double the length and width, okay, so I'm going to get that big square on the outside. There's my original square, and I double it. By what factor, by what multiplier? Okay, so this is really important that we're now talking about factors or multipliers. Okay, so that factor is a multiplier. By what factors does this area increase? Well, if I draw that in, I can see I went from 1 square to 4 squares. So the increase is by increase. Okay, and again, we're not going to say we added 3 squares because we're now talking about a multiplier. What is a multiplier? Is the increase is 4 times. 4 times 4. Okay. What about if we triple? Okay, if we triple something, so the factor area increase is going to be 4 times. Okay, if I triple, right, here I start again with the same square. Okay, this one here, this is my starting square. And I triple the length, triple the width. By what factor have I increased this area? How many times more squares do I have? Okay, and again, we're not talking about the actual adding of area. We want to know the factor increase. So what happened here? We went from 1 square to 9 squares. We have an increase here of 9 times. Okay, so if I increase the length and width by 3, I get a 9 times increase. Now, I'm going to just stop there. I want you to kind of think, okay, well, what is the relationship here? Well, clearly if I the length don't increase the same way as the areas do, okay? But how are they changing? It's not, like, how is this affected to this? How does the length affect the area, the squares? How does this length affect the number of squares? How does the length here affect the number of squares here? Okay, so then we have to think, well, these are, how do I go from here to here? If I can understand that, I could probably figure out how much increase, how many times increase I'm going to get for 1.5 times. And then we're going to generalize for n.